All right, so what we need to talk about are differential equations today and basically um, what we do with them. Differential equations, there's actually a college course called DiffEq. It was one of my favorites because it was easier than normal college classes. Basically, your differential equation is an equation with a derivative in it, like 3y prime plus 4y equals e to the negative x. This is a differential equation. And in the reading, you should have checked, well, you were reading, I'm sorry, they talk about a particular solution and they talk about a general solution. So the first example, I'm going to show you what a general solution, actually I take that back. First I'm going to show you how to verify whether a equation is a general solution to a differential equation. So I'm going to verify, I'm going to use this one I have right here. I'm going to verify that y equals e to the negative x is a general solution to this differential equation, 3y prime plus 4y equals e to the negative x. So to verify that this is a general solution, sorry, bad handwriting, I'm first going to take the derivative of my equation that I have here. So y prime would equal, the derivative of that would be negative e to the negative x. So how would I verify that this is a solution to this differential equation? Well, first thing I'm going to do is I'm going to solve for y prime, so it's actually set up as more of a derivative. So y prime equals e to the negative x minus 4y all over 3. Okay, now here's where you just have to do some algebra to manipulate what's going on here. I know that y prime, these two y primes are both the same y prime, so I can substitute in for this y prime. I can put in negative e to the negative x equals e to the negative x minus 4 times y. Well, I know that y equals, from right here, e to the negative x, and then all over 3. So basically I substituted in for y prime and y using the equation, the general equation that they gave me. And if you simplify this, you're going to see you get negative 3 over 3. So you're going to get negative e to the negative x equals negative e to the negative x, which verifies it because you got the same thing on both sides. Anytime they want you to verify, you just get the same thing on both sides. That's how we verify. All right, so I'm going to do the same thing. First, I'm going to verify that 3x squared plus 2y squared equals c. So this is a general equation, general solution. I'm going to verify that this is a general solution to the differential equation 3x plus, nope, hold on a second. I wrote the wrong thing down. All right, so I found my equation here. I want to verify that this is a general solution to the differential equation 3x plus 2y y prime equals 0. So first I want to verify. So I'm going to check to make sure this is right. I'm going to verify this. And, well, you can kind of do the same thing that we did before. I'm going to take the derivative of this side. So I get 6x plus 4y times y prime, because you got to do this one implicitly. We learned that last year, implicit differentiation, equals the derivative of a constant is 0. So if I solve my differential for y prime is going to equal negative 3x over 2y. And if I plug, you can do this either way. It doesn't matter how you plug this in. I'm going to plug y prime in over here. So I get 6x plus 4y times negative 3x over 2y equals 0. And you've done enough algebra in your life that you know this is going to be 0 equals 0. So it works. So that's the first part. Now what I want you to do is we're going to find the particular solution. So the particular solution is basically means find what c equals. So if they ask you for the particular solution, they want you to basically find C, which means they'll have to tell you at what point. So we're going to find C when y equals 3 and x equals 1. And this is basic algebra. You plug it into your general form. So I get 3 times 1 squared plus 2 times 3 squared equals C. So that's 3. That's 8 times 2. That's 16. So that's 19. So C equals 19. So the particular solution would be 3x squared plus 2y squared equals 19. And this is going to lead right into what we're going to do tomorrow with something called slope fields. So basically what that was saying is, I'm just going to draw a nice little simple picture. Your general solution could be like, let's say they're parabolas, a whole bunch of parabolas. Okay, your particular solution is you pick one with the point, what point did I use? 1, 3. So let's say I picked this one. Okay, that's the difference. The general solution would give you all of them. So C could be anything, so you'd have a whole bunch of graphs for your general solution. Your particular solution has to go through a point, so it narrows it down to just one function. All right, that's it.